Hey, welcome back to the Routing Loop. Another episode. We've got some good stuff here for you folks today. I'm Matt Lewis. I work for Amazon EC2. We've got James Wenzel. I'll do your intro for you because everyone knows you, James, but also Adish and Matt. Adish, do you want to just say hi to everyone? Tell us where you're from. What do you do?
Yeah. Hey everyone, my name is Adish Bove. I'm a product manager with Amazon Route 53, the DNS service from AWS. I'm based out of Seattle, and we're to talk about something very interesting that hopefully you've heard about already, but we want to talk about some more.
All right. And Matt?
And hey, I'm Matt Ensko. I'm a principal engineer at AWS Route 53. I'm based out of the Washington, D.C., or truly Arlington area, so that nobody throws some snowballs at me. Pleasure to be here today.
All right, great to have you folks. So today we're going to talk about secure global DNS resolution, and we're going to introduce Route 53 Global Resolver. And so today is actually part of our reinvent series. I say reinvent because we're redoing a lot of the reinvent sessions that we saw at reInvent this past December. And so you folks actually did a breakout session on Route 53 Resolver, right? So we'll dive into some of those slides, but the idea here is actually not to do a complete redo of the session verbatim. We're going to be doing questions, dive into a bunch of answers. Wenzel has a bunch of stuff that he wants to bring to the table.
I will interrupt. Have no fear.
We will both interrupt you folks. And as always, any questions in the chat, please pop them in there and we'll stop. And this is live, so ask away as well. All right, so I think you've got some slides. Do you want to bring them up and we can start talking about maybe why folks would want to use the Route 53 Global Resolver and what it is? What are we looking at?
Yeah, let's talk about that. So we covered a lot of ground already with breakout session. I don't want to go into all of those details, but I want to start about what really got us over here and what were some of the key issues or challenges we heard from our customers. And we continue to hear them because since we've launched the preview at reInvent, it's a lot of customers already using this and getting a lot of benefits from this. Just to reiterate, the things that we heard from customers primarily were challenges around split DNS management. So we get a lot of customers saying that, hey, we have our on-premises data centers, we have our branch offices, and we have rules that we need to maintain for splitting query traffic between private domains going out to AWS, hosted on Route 53, and traffic going out to the internet. And that operational pain just multiplies if you have multiple data centers or if you have multiple regions that you need to now failover or reach out to. That was the key issue that we heard from a lot of our customers that Global Resolver aims to solve. Especially when you have different DNS views for different source traffic or source instances or source clients. What we also heard from a lot of our customers was the need for DNS filtering. And DNS exfiltration continues to be a key issue for a lot of our customers who have traffic going out of the internet. This continues to be an issue or challenge to prevent any exploitation of data that can happen over DNS protocol. And so what our customers previously did was they maintain appliances on site, or they had traffic split out and going out to a separate SaaS application that did DNS filtering for them, just adding to the operational pain of maintaining all of that setup.
So were folks basically deploying their own on-prem DNS resolvers or something like that they could set some rules to do? That sounds like a pain. That's something you probably don't want to do, right? If you're using the cloud. Also, what I will say is, and maybe you folks can back me up, the things that we're seeing here are real customer requests. These are customers coming at us saying, "Hey, we want to do this thing, and we need this feature." If there's anything else that we don't cover today, pop it in the chat because you've got product management and engineering on here today. So you have their ear. If there's anything around DNS that you want to see in the future, now's your chance. All right, Adish, let's keep going.
Yeah, no, that's a great point. We are always looking for more things to add to this, and another key challenge we heard from customers, besides what I just mentioned, was they have to maintain this across multiple regions. And setting up or replicating that forwarding infrastructure and filtering infrastructure in every location becomes very tedious, error prone. But what also matters to customers is high availability of their query resolution, especially for private applications that are hosted. And so failing over between different regions of AWS becomes tricky and hard if they have to maintain all that logic on site on their on-premises. And so that's what we aim to achieve with Global Resolver to solve these key issues. So with Global Resolver, we launched this at reInvent. This is in preview, and essentially Global Resolver is a anycast DNS resolver that can resolve both your public queries out on the internet, but also private domains associated with Route 53 private hosted zones. The key feature of this is that it can resolve queries from anywhere as long as the traffic's coming from authenticated clients. And I'll get into how you can authenticate your clients, what are different options you'll have. Another key feature is that you can filter traffic. This will help you minimize DNS exfiltration, reduce the attack surface for your clients on site. And at the same time, you can also encrypt traffic. So any query traffic going from your clients to our DNS resolver, we see a lot of customers saying that, hey, I don't want to open that traffic out to man-in-the-middle attacks. I don't want anybody sniffing my traffic around my privacy. With Global Resolver, you can enforce DOH, which is DNS over HTTPS protocol, or DNS over TLS protocol, which will help you encrypt that traffic. And then you can also log all your traffic in a single place, so that reduces the burden on security and networking teams to gather all those logs from different locations and instead have all of that in a single place for auditing. We'll talk about latency resilience in a bit, but Global Resolver is optimized for improving your latency and also your resilience so that you're always, your query traffic is always routed to the closest region from your source location so that you automatically get routed to the closest location.
And so one thing I'm noticing here, Adish, is it's actually in preview today.
Yeah.
If someone wanted to use this, do they sign up through is there an online form, or do they have to talk to their account team, or how would you get access?
It's they don't have to sign up separately. You can directly come to the AWS console and start using it. When we say it's preview, it means that we are today available in a limited set of regions, and we are also in free trial, which means that you don't have to pay for it. Once we go GA or general availability, will be in more regions and will also be priced at that time.
Okay.
Also, should they consider like using this only in their test and QA environments? Don't use it in prod, or is it okay to use that in prod if it's in preview?
It's totally okay to use it in prod if they're comfortable using it there. We do expect that most customers will start using it in test accounts to begin with, just because they want to get their feet wet. But it's hardened service, so you can start using it in prod.
Cool. We actually have a question from hirings, which is kind of off to the side, but seeing as how we have two of the top Route 53 folks on the channel today, I'm just going to read it out, and then please either one answer. Talking about DNS, yesterday there was an issue with AWS and resolution for CloudFront domains, returning NX domain errors. How could we work around or prepare for these kind of issues?
Yeah, I think it's a really great question. I saw a little bit of this going around yesterday. I know this was localized to CloudFront domains. I think, unfortunately, we haven't seen the full RCA published on this one quite yet, so I don't know that we have the full data. I would expect that AWS will be publishing some guidance on that, or you can reach out to your account teams to get a little more details on that RCA moving forward in the short term. Tough issue. I think we were able to respond pretty effectively, but again, hate to see DNS making the news for availability issues.
Yeah, I actually had to reboot my laptop when that happened. I realized it wasn't me.
Yeah, I know, me too.
I was like,
I think I
"Is my
rebooted mine
laptop
twice.
broken?" Yeah.
It's never
And then
DNS.
I saw the alert. And I was like, "Oh, okay,
Yeah.
all right, it's not me." Yeah.
Yeah, everyone's favorite haiku, right? Yeah.
Right.
Well, normally, I mean, we focus on a lot of networking stuff, and normally people point at BGP or something else. But I think DNS and BGP have got a lot of flack over the last couple of years. All right, let's keep rolling here. Let's dig into some more details.
Yeah. So I want to first help everyone see how this all looks together, right? Like you may have multiple data centers, we may have even roaming clients. And what we saw previously was, hey, I had to have separate DNS connections or forwarding from each of these locations coming into AWS, and some of it splitting into the internet. Now I just have to connect one Anycast DNS resolver that does resolution for me, both for private hosted zones, public hosted zones, and also helps me filter traffic out to the internet, all in a single place. So that takes away a lot of that pain of maintaining separate forwarders, separate logic in every single location. So then we go deeper into how that actually happens. We see that split DNS, which is one of the key use cases for a lot of our customers. With this product, you can associate all your private hosted zones that you want to be resolved using Global Resolver for your clients, and get them resolved from any location. So you may have a location based out of United States or Canada or maybe in Asia. And instead of now creating separate forwarders into the closest location, you specify or direct all that traffic from those clients directly to Global Resolver, associate those private hosted zones with Global Resolver, and then you can have those private hosted zones resolved from any of those clients. I do want to mention that this is internet reachable. So all your traffic this is internet reachable Anycast IP. So all your traffic will be going out over the internet to resolve traffic for both private hosted zones and public hosted zones. Which brings me to the other point about authentication, which is critical. This is not a public open DNS resolver. Even though it's an internet reachable DNS resolver, it is only authenticated to the traffic or the clients that you authenticate with us. And there are two ways that you can authenticate. One is using source IPs that belong to your organization or the clients that use, or would be using Global Resolver. If you require something that's more static, you can also use access tokens that we will vend and that you can deploy into your clients. These access tokens will be authenticated at the time when the query arrives at Global Resolver to see if it is one of the tokens that you created for your Global Resolver before taking the action to allow or deny. By default, all traffic will be denied, so only the ones that you authenticate is actually allowed to be resolved by Global Resolver.
Can you give us a little color to what authenticated requests look like? I mean, for most of the folks using DNS, right, we go into our browsers or we type in a name in an application, it just comes back. And the idea of authenticating it, this is an extra step that most users and I would assume some of our customers don't fully have a grasp on. What does that bring to the table, and how does that kind of work within and differentiate between the two different types of resolution?
Yeah. I don't know, Matt, if you want to take that one, go deeper a little bit.
Absolutely. So we have kind of two methods that we allow. One of them is the more basic or simple one to set up, and that is using a fixed set of IPs that you just allow to access over standard DNS over UDP, DNS over TCP. This would be really ideal for fixed sites that you might have where you've got, maybe a data center, the egress IP for that data center that's going to be reaching out to Global Resolver. And you can just go ahead and configure that ahead of time with absolutely no change on your client behavior whatsoever. They keep doing their very basic, kind of legacy DNS requests, and it just works. For customers that either have roaming clients or that want a little bit more security on encrypting their packets, their DNS requests, and making sure that no one can sniff them on the wire. We also offer DNS over TLS and DNS over HTTPS, which are both encrypted protocols, and you can pick your favorite one. On those protocols specifically, we enable a second kind of authentication, and that's token-based. And in that token-based authentication, we are embedding a pre-generated kind of secret into the request so that it can be passed upstream to Global Resolver for validation. And we'll only allow requests if they carry a valid, pre-generated, pre-shared secret. For DOH, it's really simple. Typically, your resolution would look something like DNS resolver dot Route 53 global resolver.amazondatabase.com / DNS query equals blah, 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 foo.com or whatever it might be. Here, we're embedding an additional parameter into that request so that it can be passed upstream. And that's something that's supported by both common operating systems today, like Windows and Mac, so that you can enable this pretty seamlessly for your organization without having to reconfigure your clients. For DNS over TLS, it's a little bit more in depth, and we're using a function inside of DNS called DNS extensions or eDNS 0, where if you have your own DNS forwarder software, common libraries, open source libraries like Unbound and Core DNS and others support this today, you can inject that eDNS 0 or DNS extension option with that key and get the traffic forwarded for you, where we can then authenticate it. This is really useful for administrators who might have their own networks where they're already using a caching DNS forwarder and they're running some custom software. And maybe they don't want to have to configure those fixed IPs and understand kind of what their networking looks like. They can do it right on the software immediately today.
Okay, so know your IP addresses, know your communication, where you're coming from, where you're going, right? Once you get that all set up, then we can secure it down. Those queries will not be available unless you have the correct keys to decrypt them. And also, this is this is really great for secure communications laptops. Let's say you're sitting in an airport or you're sitting at Starbucks or some such, right? And I do know for a fact, I have seen people playing around before at a Starbucks using a sniffer on their phone, trying to get all of the laptop traffic. So this is definitely something that can secure you down. And it's great to hear that you don't have to do a lot of, let's just say, architectural gymnastics to get this to go. It's fairly on the edge, right?
Yeah,
absolutely. And I want to emphasize it's an either or. So you can pick the access token route where we generate those tokens and you share them out, or you can do your IP management. You don't have to do both. And so pick the one that's right for you that meets your security posture and your clients where they're at.
We got a couple of questions here. Dominic, long-term friend of the channel. Welcome back again, Dominic. I said hi to you over chat. When should we use DOT versus DOH?
Yeah, for the security properties that they bring you, they're both very similar. You're both going to have encrypted packets, and they're going to prevent that sniffing on the wire. So great properties either way there. For Global Resolver specifically, the way that you embed that token is going to be a little bit different. So we tend to see folks that are using a centralized DNS forwarder software already using DOT, and folks that want native support on client devices that might be running Windows or Mac or something else using DOH. But it's really about your clients and what they're able to use. Either protocol is great from a security point of view.
So we're just basically talking about the functions and features that the client can support over one actually winning a battle against the other.
Absolutely.
And then we have one other question from Ken, another long-term viewer of the show. Hello, Ken. Are there any guides are available to set up the access tokens? I know that, I know, Matt, you put up a blog or something like that, but do you guys have anything that you specifically want our viewers to look at to learn more about these, or is our docs enough?
Yeah, I think our docs have some good information about how to set up the access tokens for different operating systems. Happy to share them right here.
Cool. And then again, more questions coming in from Tech First, more of our standard viewer base. Hello, Tech. Do we need anything, to allow anything on the client devices security software like CloudStrike or Zscaler? So do we need to worry about poking any holes for firewalls or anything like that, or any of these particular inspection devices?
Yeah, absolutely. So maybe two parts to this answer. One, using DOH with this embedded access token is not going to require any additional client software on common operating systems. So the native OS configurations will support this. If you're running additional firewall software or filtering software, all the ones that I've seen out of the box, including CrowdStrike and Zscaler, will support custom DNS resolution configurations. And you may need to update that configuration to support Global Resolver and make sure that it's called out that this is allowed traffic, but they do have support for that today.
And then, of course, I'm going to ask, knowing the answer, but I'm going to ask anyways for folks. CloudFormation API access, is that all available, or is this? I know it's during preview, so is it available out of the box, or do we have to wait for some of that?
The APIs are there today. The console, AWS console, is there today. I believe our CloudFormation support is coming as part of our general availability launch.
Got it. Cool.
Yeah.
All right, folks, why don't you guys keep rolling, and I'll myself and Matt will keep interrupting you as questions come in.
Awesome. Let's get a little deeper into the global resolver access. So authentication is one piece of it. The other piece of it is how do you actually have different DNS views for different source traffic? So a use case that we typically hear is that, hey, I have like a bunch of corporate data centers. I want to have a different DNS view for those corporate data centers that's separate from, let's say, my roaming clients. I don't want my roaming clients to be able to access certain domains while they are on the move, but it's okay for my corporate data centers to access them or resolve them. And so we introduced this concept of DNS view in Global Resolver, where you can define and associate different domains, essentially private domains, or even DNS filtering rules for different access sources. So you can say, hey, I have these set of sources that belong to IPs X, Y, and Z, and I have these other set of users that belong to a separate user group, which are identified by access token ABC. And essentially, you can create different rules for these two groups of sources. That gives you more flexibility, and it also gives you a level of granularity where you can then say, I don't have to essentially recreate an entire version of Global Resolver for different sets of users. I can use the same Global Resolver, but have a different DNS view for each of those different source traffic. And so that makes it super easy for a lot of our customers who may have, let's say, multiple users globally distributed with different security requirements or separate requirements for resolving traffic. These may be guided by regional rules, or they may be guided by compliance reasons. And so DNS views just makes that much easier for customers. And you can add more DNS views. You can change DNS views depending on your compliance guides or changes to your requirements. And those will automatically be deployed and take effect immediately for all of your clients.
And I'm assuming we're using some kind of anycast there on the front end to route users. Do you want to talk about that?
Yeah, so we do use anycast, but essentially DNS view is nothing but a logical grouping. So you're associating that logical grouping directly to Global Resolver. When the request comes in, it tries to check whether the access token or the access source belongs to any of the DNS views before taking the action.
So you're basically saying everyone can come in through the same front door, but based on a particular classification, a token or source IP or something like that, we're actually going to use this policy or that policy to route you or to respond accordingly. Okay, very cool.
And do you get one Anycast IP, or do you get a set? How does that look? And how do we convince customers that this is redundant and secure?
Oh, that's always the $1 million question.
What's the $1 million question?
That's Matt's favorite topic. So
absolutely. So you do get a pair of Anycast IPs today. That pair is backed by, so as called out, we do route through the AWS Edge network on our way into the region that that the customer gets to choose when they set this up to process their traffic. On the AWS Edge, that pair of IPs is backed by redundant sets of hardware and routing devices, which buys us a lot of goodness on the edge as far as availability goes. On the regional side, we also have a completely redundant set of hosts that are going to be responsible for answering your traffic, such that you have a really great posture. From a service point of view, we have a lot of belief that it's very hard for us to impair both of these redundant sets, and that buys you a lot of goodness. Additionally, when customers configure Global Resolver, we ask that they pick at least 2 AWS regions, such that in the very rare case that we're having some networking problems or a service-side problem in one of those regions, we're able to move the customer's traffic over to that second region automatically, kind of invisibly on behalf of customers, where you no longer need to go and configure your own clients or some kind of middle box to do that failover on your behalf. The service is managing it for you. You can go more than 2 regions should you desire to do so, but we ask that you pick at least 2 as you configure it.
So just so that we can frame it, because we've talked quite a bit about services like CloudFront and AGA here, where we have the POPs, basically placed all around the globe, and we're bringing the AWS backbone directly to that POP. So this is a very similar situation. Are you using new POPs, or are we leveraging existing ones?
Those existing POPs. That's right.
So good. Yeah. So those are all pre-built. Cages, super secure. Everything is redundant. Yeah. No. Perfect. And then, of course, the $1 million question that we usually get asked. What's the SLA?
I think we have not announced an SLA in preview, and we might have to take that one back for future.
Yeah.
Okay. Just so you know, this is DNS. This is a core feature everybody relies on. We always joke about it failing, and then we always curse it or bless it. So just know that our audience is going to want to know that answer.
We are discussing.
Isn't Route 53 one of the only services that had a 100% uptime SLA? I think I don't know of another AWS service that actually can say that.
Yeah, the authoritative side of the house does have that today. Global Resolver being its own standalone service, I think we've got future exciting developments for that one.
Very cool. And as of course, we have to always remind our audience, we don't talk about any roadmap items. You can tell us what you would like to see on a roadmap, of course, as Matt mentioned earlier, but we can't really talk about anything that's being released or coming up soon. Otherwise, I think the AWS lawyers just come out of nowhere and just start or throwing paper at us. Question from Tech First: is the control plane still on US East 1?
The control plane for this service is in US East 2.
Yeah.
Dodge that bullet, huh?
All right, let's keep going here. I think you guys have a bunch more content, right? So we're about 30 minutes in.
Yeah. So we love talking about DNS security, but we also want to make it super easy for our customers to use it. So that's where we introduce these thread and content categories. Essentially, these are predefined, preset categories of domains that are classified based on threat type. So it can be DNS threats that you want to block. So customers may say, hey, I want to block malware or phishing or spam because they are considered bad, or this botnet command control. So by default, I want to block all of these different categories. But there may also be customers who may say, hey, depending on whether this traffic is coming from my roaming clients or whether it's coming from an on-prem location, I may also selectively want to block certain content types. So web content associated with adult sites or gambling sites or cryptocurrency sites. These domains, I don't want any of my end users to be resolving to. So, you may have an employee working out of Starbucks, and I don't want them to be going to social networking sites when they are remote. I just want to block them. And so you can create these level of, going back to the whole DNS view structure that I talked about, you can create a different DNS view for your employees belonging to these different locations or access tokens, and then also create rules on top of that to say, hey, I want to block them from accessing these specific domains. So it just becomes so much easier for you to manage, because you can add or delete any of these rules depending on your security requirements, and at the same time log them to ensure that they're actually being enforced for all those users and you don't have any gaps in your security posture.
Another great thing about this too is, as we're talking about other services such as Lattice and whatnot that uses IAM policies to restrict access, these are great things to think about when you have to talk to an auditor, right? Export these rules and show
Yeah.
them. These are literally part of your security posture, literally part of your firewall posture. So don't sleep on these rules as well when you get audited and saying, hey, prove to me that XYZ cannot reach 1, 2, 3. This is a perfect example of that.
That's a great use case. We hear that all the time, where you have customers who come from certain regulated industries who say, hey, I have an auditor and I have auditor need to say that I'm blocking all traffic to cryptocurrency, or I'm blocking all traffic to malware. How do I prove that? And here's the way. You can actually create a rule and then show them in the logs to say, look, it's blocking all these traffic categorized as malware. And so that just becomes so much easier, even for the auditing use case, which is also something that we talked about earlier, which is you can log all your traffic in a single region of your choice, so you don't have to go hunting in different regions and collate these logs to bring it together.
Yeah, it's all centralized. It's perfect.
Are we using a third party to classify sites? Are we subscribing to something, or do we have our own classification engine or something like that?
We do use a host of different sources for both threat and content categories. Some of these are from third parties. Some of these are internally sourced from AWS sources. So it's a combination of both. So yeah, and at the same time, what you see over here, threat and content, it's a mix of domains that are sourced from all of these different locations or sources.
I feel bad for the home and garden sites that are now being blocked. I guess I'll have to buy some shovels and gardening tool implements on my own time. Oh, there's a question here from hiring. So I don't know, Jamie, if you want to bring it up. I don't have access today, but are content filters available for current DNS firewall?
Yeah, great question. No, it's not available today. We have a few of the threat categories that are available to DNS firewall. That's where we see the most use of DNS firewall on the VPC resolver. They want to block traffic out to threat categories. But it is something that we're thinking of. We hear this from our customers all the time that, hey, they want to see this parity. So yeah, it's something that we are thinking of.
So hirings and anybody else, make sure you make your PFRs, talk to your SA. I know you were going to say the same thing, Matt. I just had to jump in.
You got it.
Yeah.
And then there's another one here from Ken. What about the network firewall URL filtering categories?
Yeah, I know Network Firewall recently announced their URL categories. They have effectively very similar or the same content category names as we do. So we do have the plan to, or we do want to make sure that you get the same names across both of these. I don't know if there's a specific question on Network Firewall URL categories that I can answer.
Yeah, Ken, if you want to ask anything a little bit more fine-grained about that, please let us know. We'll continue on, but if you ask quickly, we'll bring it up.
I want to talk about advanced DNS protections because this is something. There's a question. Can we use URL filtering insert for now?
Yeah. So I guess on top of the URL firewall URL filtering categories, can we use URL filtering instead for now, as opposed to not having that, I guess?
So they would work differently. Domain filtering essentially is, or domain categories essentially blocking domains over DNS traffic. The URL filtering that network firewall provides would be blocking traffic for your HTTP traffic. So effectively, they're different.
Okay, cool. And then this one last one too, just to address it. Is WAF a separate entity or is it service integrated? WAF, I believe, is still integrated with our API gateway. It's still integrated with our CloudFront and our ALB, but I do not believe, is WAF integrated with Route 53?
WAF is not integrated with.
Yeah, so it's still a separate entity. So you're still going to have to figure out your flows, your resolutions. All of that's going to happen before it hits your WAF. So you can think of this Route 53 and Route 53 feature as an edge to our edge. right? Even before you hit our edge, you've got to resolve. So that'll happen even before it gets to WAF.
I think WAF's a great service, but in this case, I mean, you folks aren't using WAF technology or anything related to WAF under the hood. It's a completely separate entity in this case, right? So very cool.
Yeah, we do. I would call out. We do make use of some of the same protections that WAF has with Shield for this service. Some of the same DDoS is used to protect the service from external threats, and customers who onboard to that get those things automatically in a managed way when using the service. But that's the Shield part of it, not the WAF part.
And is Shield Advanced a part of this, or is it just Shield?
Yes.
Advanced.
Okay, so you can get Shield Advanced with this. That is very cool.
Yeah, effectively we're using Shield for protecting the service from DDoS attacks.
And that makes sense. I mean, Shield, for folks who haven't used or seen Shield, is basically our in-network DDoS protection system. And so it makes sense when you've got a service that's sitting on the south end of, I guess you could call them our transit provider links or our transit network, that you would use the same protection mechanisms as well, right? I mean, that just makes so much sense. So. All right, let's keep rolling with some advanced DNS protections.
Advanced DNS protections. This is for customers who need to go a step up from the threat content categories. So threat and content categories works best if you want to do quickly block domains belonging to certain categories. But there could also be domains that are advanced or not immediately tracked by these domain categories. So you may want to add on to additional protections. One of the categories of these advanced DNS threats that we see is DNS tunneling, where effectively you have a client which is already infected with a malware, and you have a command and control server, and you have this malware creating this tunnel between the client and the command and control server. And then effectively that tunnel is used for exfiltrating data over DNS requests and responses. Another advanced DNS threat that we see very common is DGAs, domain generation algorithms, where in this case, the attacker just creates multiple domains, which are very hard to track. And because they shift through all of these multiple domains to avoid detection by security vendors or by threat feeds. And so it becomes a game of whack-a-mole because you're trying to block something and the attacker's already moved or shifted to a different domain to carry out its activities. And so both of these are prevalent today, and something that we see a lot of customers saying that, hey, I want to block against these, especially for my highly sensitive clients or workloads sitting on premises. And so with Global Resolver, we do have these protections baked in where you can enforce both of these protections directly. It looks for anomalies in your queries, looking for things like length of the domain or query patterns in that domain. You can also customize it depending on your risk appetite. For example, you can say, hey, I want to block the most highly probable DGAs, but I just want to put an alert on the low probable so that I'm not creating any availability issues for my clients. And they are real time, so they are investigated, processed, and blocked in real time as your query is passing through Global Resolver. So this becomes an additional toolkit for a lot of our customers who want to have that protection. We already talked about encryption, so I don't want to spend a lot of time on this, but this gives our customers an additional layer of protection for their queries in transit with DOT and DOH. And then query logging, this becomes a neat tool. This makes it easy for teams to quickly audit and keep everything in a single place. I want to go over the failover and multi-region because this is one of the key benefits of Global Resolver. Matt, I don't know if you want to take this over because this is something that you covered a lot in depth during our reInvent session.
Yeah, I think we alluded to it a little bit earlier, but being able to automatically fail over between the regions that you as a customer select to have processing your DNS workloads, we see as a really huge benefit of the service. We consistently heard from customers that it's really hard to get this right. It's hard to to set up. It's hard to test and make sure that it works appropriately. And for something as critical as DNS, like, it just needs to be absolutely bulletproof. And so we're incredibly excited to move some of that complexity off of customers' plates and try to manage it for them through the service. So as we previously said, when you set up your global resolver, you're going to pick at least 2 AWS regions where we're going to be processing your DNS traffic. We, under the hood, are going to configure a slew of availability zones and compute and resources in each of those regions. And we're going to be responsible for making sure that your DNS configuration, your filtering rules, or your private hosted zones, or whatever else you might have, gets replicated into those regions. So you make your changes in our one kind of control plane, and we get it published out to all of the regions on your behalf. And then when any of these kind of networking issues, server-side issues, AWS issues might occur, we have the ability to quickly fail over to the next region on your behalf, and that's going to happen automatically really quickly. That means that your clients might see a little bit of extra latency as traffic moves from the region that they were previously closest to over to the next closest region that's available that you selected. But we think that's a really great trade-off. Maybe you get an extra 30 milliseconds of latency on your DNS request, but it just keeps getting answered regardless of those failures. And as we called out earlier, because we're using those AWS Edge locations that are distributed, and I don't know what the count is today, but it's more than 100. In all of those different edge locations, we're able to get your traffic onto the AWS backbone very quickly and minimize those networking disruptions so that you're able to get your clients what they need as highly available as possible.
And then just one other call out too is just to circle back to those Anycast IP addresses. This is also pretty cool if you guys think about it, because then you don't have to put in any new IP addresses. You're not going to fail your cache, right? You don't have to clear that all out because there's a DNS change. All of that's abstracted for you underneath that Anycast layer, which is pretty slick.
Yeah, absolutely. Those Anycast IPs help not even just in a failure scenario, but we heard customers who said, like, look, I'm standing up all these sites and trying to figure out, this site uses this region primary and this one's secondary and this other site has a different second. Like, it's just complexity that you don't want to have to manage. And so by using these two kind of fixed Anycast IPs, you just put the same things on all of your clients and they all get routed to the right place.
So one question I have too, just thinking about that, based on source destination for authentication as to where to send your view, does that also work with geoloc, or is this something that's separate?
It does. So maybe two answers. First, your clients are going to get routed to the closest AWS region, the closest edge pop via Anycast, and then the closest AWS region behind that to get their answer. And then second, the answers that they're getting are going to be based on the location that they're connecting through. So in theory, your clients are close to, let's say, US East 1, they're going to be getting geolocated answers that are nearby that region. We do also support the DNS extension that allows a client to specify their original IP. So if you have a DNS forwarder, there is this embeddable EDNS client subnet or ECS field as part of DNS, where you can say, hey, I would like geolocated answers based on this IP, not the resolver's IP. And we support that fully. There's an additional flag that you can turn on where we will look at the client's source IP, and we will embed that IP as the EDNS client subnet when we talk to upstream name servers. So if you'd prefer to get answers that are close to your clients and you're willing to let us forward that information to the upstream name servers, we can do that for you as well.
Very cool. Ken also asks, he says, stupid question, but as we all know, the only stupid question is the one not asked. Can the global resolver Anycast IPs be private?
Not today, but do please reach out if you have that need, and we'll take a look.
Yeah, so if you're looking for a fully private global DNS resolution system, please, same thing, PFR, let these folks know why, what the use case is, all of that fun stuff so that we can go to our leadership and get it approved.
And to let you know, like, we do have our route first resolver, which is an existing recursive resolver that comes with all of your VPCs. You're calling it now VPC resolver, but that's essentially a private recursive resolver. It's not Anycast, but that's the one that exists within your VPCs. There's one small use case that I also want to call out, which is data residency. which is something that we hear from a few customers, which is, hey, I do like the Anycast resolution, but I don't want this to happen across multiple different regions or countries because I'm bounded by data residency regulations. And so with this, you can also create different global resolvers for different sets of countries or regions. When you onboard global resolver, you get to pick the regions where you want global resolver to be deployed or hosted. And so you can create essentially multiple global resolvers for different sets of countries or different sets of locations, depending on your data residency needs. So for example, you can create for country A, which may have region A and region B, you can create separate global resolver with separate Anycast IPs, separate rules, which is different from what you would have for country B, for instance. And they would continue to function separately. So that way you are complying with your data residency regulations. So when should you use global resolver? This comes up with a lot of our customer conversations because a lot of our customers already have setups in place. They may have inbound resolvers, they may have forwarders, they may have VPC resolvers. What we tell customers is, if you want consistent DNS resolution across all your customer networks, but at the same time you want to have, you may have disconnected sites with internet connectivity. You may want to bring them under the purview of your security admin, or you want to bring them under the purview of the same security rules. Global resolver makes sense. You may have disconnected sites with internet connectivity, and you may want to have good failover mechanisms for those. Having all of this, or having these use cases or scenarios, fits perfectly well for global resolver because it helps you take away a lot of that pain and burden of managing different forwarders, managing different security rules, and rather having a single site or a single endpoint that you can connect to instead.
So we have a question here from Tech First. Multi-region failover, is it separate from application recovery controller? So just back on our previous topic.
Yeah, it is separate. We don't require that you configure application recovery controller with your global resolver or do anything additional when you're configuring your global resolver to get the multi-region failover that we have today.
And I'll throw a link to application recovery controller in the chat here. I think I thought that was an interesting service when we first launched that one. Okay, let's keep rolling here. We've got about 13 minutes left, so I don't know if you folks have any customer case studies or kind of some real life workings on how global resolver is used in real life.
I can do a demo if
you want to do a demo. Absolutely,
we love demos.
We won't hold it to you if something breaks, but
let's do that.
I think our audience actually appreciates it when something breaks even more, because we get to show them how we go through it.
All right, just give me a second while I bring up my account.
In the meantime, Matt's going to completely speak in Route 53 to Bind 9, and you can hear the audio differences between the two.
All right, so open your etsyresolve.conf and start with 4. No, I'm out. Yeah.
All right, here you go. And hopefully able to see my screen.
We can see your screen. You might want to make your font just a little bit larger, though. If you can just do the, there you go.
So I already have a couple of global resolvers that I've pre-created. I don't want the viewers to go through to see the process of creation because it's just going to take some time. But effectively, this is a global resolver that I've created. I have 2 regions that I have already created this with. It's US East 1 and US East 2. So this is where all my Anycast resolution is going to happen. I have not configured a observability region. This is optional, but if you want, as I said, if you want all your logs to be deployed in one single region, you can also configure this. I get 2 Anycast addresses with this, and then I can create multiple DNS views for different sets of users over here. Now let me go back to the test one, which I had created for this demo. I have 2 DNS views over here. One for work location 1. This one has a little bit more restrictive DNS firewall rules. So it blocks all your job sites, malware sites, shopping sites, everything. And it also allows you to resolve a private hosted zone. So I have this private hosted zone created in my account, which is also associated with this DNS view. And also have this access source. This access source points to this CIDR range, and it's using the regular UDP DO53. I don't have any access tokens at this point. And then I also have a second DNS view, which is a little bit more permissive, which only blocks malware, but it allows you to access any other site, job site, or any access site you want. Now let me sign into my. Sure, I'm signing in.
We have a quick question on who pushes the Anycast IPs to the end user's machines. Should I talk to local IT to add these values? How does that work?
Yeah, those are going to be the DNS resolver IPs that are either advertised via DHCP, so whoever's running your DHCP can configure those, or configured locally via etsy.resolve.conf on a Linux system, or probably through Windows or Mac settings otherwise.
Let me get my instances ready. Right here. So I have this test instance.
While Adhesh is getting connected, I'll call out, we do have in our docs some examples of how to configure your local operating system should you want to test this and play with it.
Yeah. So I'm going to test this out, and hopefully it works. Where I'm going to try and resolve Amazon.com. This is the IP for my global resolver. So it's going to resolve using global resolver. And it says very rightly that this recursion is denied. And that's because, as you can see, we had created this rule to block any shopping sites when you're in work location 1. You can try that again for another job site, maybe this one, and it will say the same. Its recursion is not available. Now, maybe we try a second instance, which connects to work location 2. And this one should be a little bit more permissive. So let's try going back to. And this one will return you the IP. So this one's going through, great. I'm in work location 2 now. And it'll also allow me to access any job sites if I want to. What we'll also do is it will allow me to resolve any private hosted zone. So I had created this private hosted zone in my account associated with my DNS view work location 2. And if I click this one, this will give me a response with the IP. So as you can see, it's allowing you to filter traffic based on your location, based on the DNS view, that rules that you've created. It also allows you to resolve any private hosted zones if you have any associated from any location. And so this becomes very convenient. It becomes easy because I can just go ahead and add more rules. I can add more private hosted zones, and I can just switch and add additional locations that I want for resolution. So effectively, it makes life easier for a lot of our network administrators and security admins. And that's the demo.
Pretty
Very
easy.
cool.
So we've got about 6 minutes left, 5 minutes left now as the clock is slowly ticking down. Generally, this is the time when Matt and I usually like to ask our guests, Adish and Matt, if there's one takeaway that you want the audience to take away. I'll go to Matt. I'll go to you first. What do you want them to take away about Global Resolver?
Yeah, I think my biggest one is we've heard from some of our early adopters how excited they are to be able to simplify their lives, their many region, many site configurations, and manage it all in one place has been a really compelling story. They've said that they have people just spending their day jobs just maintaining this kind of config and pushing it all around and trying to make sure that it gets replicated in the right ways, and not having to have that mental load frees them up to do more meaningful work. And so super excited to hear that. Hope that it can help people have an easier time configuring their very complicated DNS configurations.
Nice. And Adish, thank you again for the demo and for also managing the slide deck. What are your last thoughts? What do you want folks to take away from this?
Yeah, I want to go back to the vision that we had when we first thought about this product, which is we wanted to make lives easier for a lot of our network and security admins who are managing DNS today across their multiple sites and ensuring that the security power and posture for their clients is maintained. We wanted to make sure that work is easy for all of our administrators, that it is secure and it's available, because those are the three key things that we always hear, regardless of whether it's DNS or anything else. So we want everyone to try this out. Let us know what you think and give us feedback. We are happy to add on any new feature, any new requirement that you may have. This is still in early stages, so yeah.
And as with every service at AWS, we love customer feedback to help us build the best service we possibly can for you folks. Well, that said, we're pretty much right on time. Matt, thank you. Adish, thank you. Jamie, it's always a pleasure. Thanks everyone for joining us here today. We'll hang around for another couple of minutes in the chat, so any questions, feel free to post them. But otherwise, we'll see you all next week on the Routing Loop. Thanks, everyone.
Thanks all. See ya.